Hi everyone, hope you are all doing well and safe. Welcome to the practical course of circuit analysis. Here's your lab instructor Nishita Alwaz. Agenda of this experiment includes 7 different sections: lab objective, equipment needed for the experimentation, theoretical background, software implementation, results and discussion part, conclusion and the task assigned. In this experiment, we will learn that how we can determine the voltage across resistor in the circuit using NI Multisim software.
The basic equipment needed for the experimentation is NI Multisim software installed on the personal computer.
Before we can calculate the voltage across a resistor, we will first have to determine what kind of circuit we are using. We basically require a basic review of the common terms of the circuit. Firstly, the current. Current is the rate at which charge flows by a point on a circuit. The current in the circuit can be determined if the quantity of charge Q passes through a cross section of a wire in a time t can be measured. The current is simply the ratio of the quantity of charge and time. Electric charge is the fundamental property of particles, ions, atoms and molecules, which allows them to attract and repulse with each other when it is placed in an electric field. Electrons have a negative electric charge. This means they attract or flow towards objects with a positive charge and repel or flow away from objects with a negative charge. Electrons are always trying to push away from other electrons, spreading out wherever they can. Voltage measures the difference in electric charge between 2 points. Greater the difference, the more energetically the two sides attract each other. Inside a battery, chemical reactions happens that produces a buildup of electrons. The electrons go to the negative end while the positive end stays mostly empty. They are called positive and negative terminals. The longer this goes on, the larger the voltage between the two ends. When you connect a wire between the negative and positive ends, electrons at the negative end suddenly have somewhere to go. They shoot towards the positive end, creating a current. The larger the voltage, the more electrons move to the positive end each second. Resistance is exactly what it sounds like. The more resistance something has, the harder it is for the electrons to push through. This slows the current since fewer electrons can pass through each second. Ohm's law is a very simple relationship between current, voltage and resistance. Current is basically the ratio between the voltage and the resistor. So if we increase the value of voltage, then our current in the circuit will be increased. And if we want to measure the voltage in the circuit, then formula is basically V is equals to IR. Understanding a series circuit. A series circuit is easy to identify. It just has one loop of wire with everything arranged in a row. The current flows around the entire loop, going through each resistance or element in order. The current is always the same at any point along the circuit, while the voltage across each resistor will vary in the series circuit. So here we have our circuit basically consisting of one battery and 3 resistances. Now if we solve the series circuit as we have discussed in the previous slide, then total resistance in the series circuit is basically equals to R1 plus R2 plus R3. So R total equals to 10 ohm. Now if we want to find out the current in the series circuit, we know that in the series circuit we have basically one current only. Across each resistor we have equal current. So I is equals to V divided by R. R is basically the total resistance, which is 10 ohm. So I equals to 1.2 ampere. And we know that in the series circuit we have different voltages across each resistance. So voltage across R1 is equals to V1, which is basically the multiplication between the total current I and the resistor value. So R1 equals to 2 ohm. So V1 is equals to 1.2 multiplied 2 ohm. So we have R1 voltage equals to 2.4, and the same procedure for R2. So voltage across R2 equals to 3.6 volt. Same procedure for R3. So V3 equals to 6.0 volt. And now if we sum up all these values, then we have 12 volt. Across each resistor we have basically 2.4, 3.6 and 6. So now if we sum up all these values, then we have 12 volts across the overall circuit. Exactly the same voltage battery provide us. Understanding parallel circuit. Imagine a wire leaving one end of a battery, then splitting it into two separate wires. These two separate wires run parallel to each other. They join up again before they reach the other end of the battery. If there is a resistance on the left wire and a resistor on the right wire, these two resistances are connected in parallel. Here we have parallel circuit. Basically consists of three resistances in the parallel fashion and also the 12 volt battery. In parallel circuit, across each branch, voltage basically equals to the voltage of the battery. Like we see that here we have three resistances. So across each resistance we have equal amount of 6 volt, exactly the same value of the battery. In the parallel circuit, we know that the formula for R total is equals to 1 by R total equals to 1 by R1 plus 1 by R2 plus 1 by R3. So R total according to our circuit diagram is 1.33 ohm. And we know that in the parallel circuit across each branch we have equal amount of voltage. So as we calculated the current value, which is equals to 9 ampere, so the voltage in our circuit is equals to 9 ampere multiplied by 1.33. So the answer is 12 volt, exactly the same voltage of the battery. So we can say that across each branch in the parallel circuit we have equal amount of voltage. In this experiment we will learn about the measurement of voltage across the basically resistor. So firstly we have to place the components of the circuit in NI Multisim software. Moving towards this block, then moving towards resistor, then pick the resistor of firstly 2 ohm and place it on NI Multisim software. Then pick the resistor of 3 ohm and place it on NI Multisim software. Then pick the resistor of 5 ohm and place it on NI Multisim software. Then moving towards the sources, then power sources, then pick the battery DC power and then pick ground. After this, arrange all these components basically in the same fashion as we have seen in the previous slide. Select battery and press Ctrl R and then click on it and flip horizontally. Then basically we have to measure the voltage across the resistor. So in series circuit we know that voltage drops are not same across the resistors. So we basically need 3 multimeters. Moving towards this block and pick multimeter, pick another multimeter, pick another multimeter. Connect with one resistor. Then run our simulation diagram. Click on multimeter, then here we have 2.4 volt across 2 ohm resistor. Click another voltmeter, then we have 3.6 volt across this R2 resistor. Then click on third multimeter, basically the voltmeter. Here we have 6 voltmeter, voltage basically. Exactly the same values we have calculated in our mathematical work. Now in the second step, we are going to measure the voltage in the parallel circuit. So moving towards this block, then basically moving towards resistors, basically basic blocks, we have resistors. So pick resistor of 2 ohm first, then 3 ohm, then 5 ohm. Then moving towards sources, then power sources, then pick DC power, place it, pick ground and place it. So now arrange all these components in the parallel fashion. Then connect ground block. As we know that in parallel circuit we have equal voltages across each branch. So we will connect multimeter, 3 multimeter basically across each resistor. Then run our simulation diagram. Double click on the multimeter 1. So here we have 12 volt of across basically R1 resistor, exactly the same voltage of the battery. In next multimeter we have 12 volt, exactly the same voltage of the battery. At multimeter 3 we have 12 volt, exactly the same voltage of the battery. So we can say that in parallel circuit we have equal voltages across each branch. All voltmeters based results of the series circuit listed in this slide. All voltmeter based results of the parallel circuit is listed in the current slide. From this experiment, we have learned that voltage applied to a series circuit is equal to the sum of the individual voltage drops. In parallel circuit, voltage drops across each of the branches is the same as the voltage gain in the battery. And we have learned the basic concept of series circuit and the parallel circuit in NI Multisim software also.
Tasks assigned for this experiment are listed in this slide.
This is all from my side. You are welcome to ask any question related to this topic. Thank you very much for listening to me.